Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Any exciting developments in science?
I saw a cute little story. Basically, there's a team from Samsung in a university in Korea, and they've come up with a way of, so if you've got a touch screen or something which you're typing on, so like on an iPad or something, where you can press your fingers on it, they've come up with a way of making flexible ones of those, which actually, rather than using electricity when you use them, it actually generates electricity every time you touch them or you roll it up or you unroll it. Every time it flexes, it generates electricity. They've got two layers of a material called graphene, which is like graphite from a pencil lead, but just a single atomic layer of it. And between that, they've put little tiny nano rods of piezoelectric material. These are the things which, have you ever seen one of those gas lighters which you squash and they create a spark?
Oh, yes.
What you're doing is you're squeezing a crystal of, possibly a quartz crystal, something similar, piezoelectric material, which when you squeeze it, it creates an electric charge across it. So you've got all these little tiny piezoelectric rods. So whenever you flex it, they build up charges on them, and that generates electricity. So it's tiny amounts of electricity, but with very efficient electronics. It could be enough to help power your sort of, probably not a mobile phone, but some kind of digital assistant or something. You might be able to get enough power just by pressing the buttons to power it.
Mm. Now, Dr. Dave, the questions are rolling in. Dom has said, a science question, how do antibacterial soaps and cleaners work to kill germs, and what do they contain? Do.
There's basically something which will either kill bacteria or, more common, just stop them growing, because actually the number of bacteria which you're going to pick up isn't that bad, as long as the number of material which get onto the surface isn't too bad, but as long as they can't keep growing. There's various ways. One of them is just to put something like alcohol in there in large quantities, which will dry out the bacteria and just kill it by dehydration, basically. And it's also not very good for them as well. Also, there's things like triclosan, which seems to have an effect of stopping the bacteria making fatty acids. So basically converting fats into things called fatty acids, which they need to create the membranes around the outside of the bacteria. And if the bacteria can't make any more membranes, it doesn't kill it immediately, but it stops them reproducing. And there are other things which, things called EDTA or terrasodium EDTA, which grabs metals from the environment and ties them up really tightly. And that means the bacteria need some metals to grow. And if there's no metals in the environment, then it's like you starve them of metals. They can't grow, and eventually they just die off.
Really?
So they basically put all sorts of different things in there, various different things, some of which affect the bacteria in different ways.
All right, okay. Well, I've learned something there for a change. Now then, John the Baker. Hi, Dave. He would like to know why they can't use a dry vacuum cleaner to clean the oil off the top of the water in the event of an oil spill. Interesting question. Good one, John. Dave?
Here's a very good question. Fundamentally, you could use something like a vacuum cleaner. You probably wouldn't even need anything as sophisticated as a vacuum cleaner to suck it up. All you'd need to do is sort of have a big sort of tank, and you make the tank slightly lower than the top of the sea, and then just sort of skim off the oil all the time. I think they do have ships which are going along and skimming off oil. The real problem is just the sheer area. The area covered in oil is hundreds of miles square. And if you imagine how long it takes you to hoover your sitting room, and okay, you could use a much bigger hoover, maybe a few 100 metres across, but it's still a huge area, and they just can't cover it quick enough. So, and the real thing they've got to do is somehow try and block up that leak. I mean, the real problem is it's just so deep.
Yeah. And
divers can't get down there, so they're having to do everything with robots.
Yeah.
And if you're trying to lower something down there, the length of cable is sort of 1.5 kilometres down underwater, and the length of cable is kind of hanging down there is really difficult.
Yeah.
And so it's just difficult to do anything down there. So technology will probably advance and they'll be able to do it safely eventually, but they haven't quite got there yet.
Yeah, sure. All right, let's get to our next question. And this one is on the text. Mike says, Dr. Dave, could scientists invent armoured glass that could be used on tanks and ships? Or is glass just material that is impossible to turn into a strong substance? That makes sense to you, Dave? So read it again.
I think basically whether you could make an arm of glass which is a good enough armour to replace the armour on tanks. I think one of the big problems with glass is it's very brittle.
Yeah.
And so if you get a crack going through it, that crack tends to carry on until it carries on until it meets the edge of the glass. And so they do have armoured glass in things like armoured cars, and the car which the President of the US drives around in has got sort of 3 inches of armoured glass in the windows, which will stop bullets. And the way they make that is with a layer of glass, thick layer of glass, then a layer of plastic, which will stop that crack and catch any bits of shattered pieces of glass, and another layer of heavy glass, which is strong, but if it breaks and it completely shatters, another layer of plastic, another layer of glass, another layer of plastic. They sort of have huge, great sandwiches of lots and lots of layers of glass and plastic, which will stop bullets. The problem is, as soon as you get hit by a bullet, there's cracks all over the surface. And cracks in glass, I mean, I'm sure you've seen it on the... they're not transparent.
Yeah, exactly.
They scatter light all over the place. And so whilst you could probably build a tank which is pretty tough to start with, it would probably be heavier than steel, because steel is a really good material. It would also, as soon as you got shot at by some kind of small bullet, or if you occasionally accidentally drove it into something, it would get covered, it would get shattered, and it would cease to be transparent because it'll be all sorts of muck on the outside. So, I mean, there are armoured glasses, but they tend to be heavier than the equivalent amount of steel, and there wouldn't be a lot of point in making a whole tank out of it.
Now, we like the idea of this one. Stephen Peterborough has said that he has taken hard drives to pieces in the past, and they have had a non-magnetic disk in them. Can you explain how they managed to write the data to a non-magnetic disk? He's one of those people that likes to take things to bits, obviously. Man after your own heart.
I thoroughly approve.
Dave?
Yes. Kind of quite surprising if you actually play with it physically. The real thing is that there is a layer of magnetic material on it. It's actually a cobalt alloy on modern hard disks, but it's incredibly thin. It's about 10 nanometers, so that's about 10 billionths of a meter. So like 1,000 times smaller than the thickness of your hair. And most of the rest of that disk is just made up of aluminium, which isn't magnetic. So although that cobalt layer might be attracted to your magnet, especially if it's a strong magnet, it's probably not going to have a major effect because it's just so small, and compared to the weight of the disk, the attraction is going to be tiny. You're not going to have to notice it. You actually only notice the magnetic fields on a really, really tiny scale, and so the head that's measuring, picking up the information on the hard disk is absolutely minute, and it's picking up tiny, tiny areas of the hard disk, and it's incredibly close. I mean, less than a millionth of a metre away from that layer. And so if you get very, very close, then there's a huge amount of information there. But if you're a long way away with the magnet, you won't you hardly notice that layer's there at all.
Let's go to the email this time. Dave in Great Yarmouth says, "Hi Sue, I recently read an article about underground nuclear explosions around the Nevada test site, and the pictures of the aftermath left large flat-bottomed round craters similar to those ones on the moon. How are these craters formed after a massive explosion underground, and why don't they break the surface?" Good question. Dave?
Okay, a nuclear bomb releases an immense amount of energy. The big hydrogen bombs, the equivalent of 1 million tons of TNT or larger, all going off at the same place in the same time. That heats material up to hundreds of thousands of degrees C, if not millions of degrees C, far hotter than the surface of the sun. And when gases get any material at that temperature of gas, and when gases are hot, they apply a huge pressure, so they push out incredibly hard. Now, a gas will push out in all directions, and basically what it's going to do is it's going to push on all the rock and squash that rock, and you get lots of earthquakes and lots of shaking. I mean, you detect a nuclear bomb going off underground by the earthquakes it produces, and it produces a very characteristic set of earthquakes, and you can work out so you know it's a bomb. And that pushing out, basically, if you've got enough rock on the top, it's not actually going to have enough force to blow that rock out and form an open crater. It will push everything out sideways. And then once it's pushed out and everything cools down again and it has a bit of time, then you have this huge void underground. And so it's pushed everything out sideways, up and down. And that void collapses, and it's only going to collapse downwards. So basically, it's pushed rock sideways, and stuff has collapsed downwards into that hole, so you get a depression, even without it coming up to the surface.
Let's go to our next question. And John, the vintage radio engineer. Hello, John. Always lovely to know that you're out there listening. He says, "Dave, are scientists working on a way to clear this volcanic ash cloud? What's the latest on that?"
I certainly haven't heard of anything. I'd be very surprised if they were, because it's just such a huge cloud. It's another one of those kind of scale things that, it's filling up cubic kilometres of air with this ash. And when it's at the volcano, it's incredibly hot. It's coming up. You can have huge problems with doing anything to it, even if you sort of did something like spraying water onto it in there. If you're not careful, then that water's going to expand and actually drive it higher. So I think long before they get at any point actually trying to clear it, they're trying to learn where it is, because something they are really concentrating on is finding out where that ash cloud was. Because part of the problem that they were having when all the flying was stopped for a week was they didn't really trust their models of where the ash was. They've got lots of computer models as to how the ash should travel when it comes out of the volcano. But if you don't really trust your models, then you've got to be very careful, because you might find there's a load of ash outside of where you think it is.
Sure.
And so what they're trying to do really carefully is work out where the ash is and find out ways of detecting the ash, and so they know exactly where the planes can't fly. And if you know exactly where the planes can't fly, there's much more space where they can fly, and they can fly around it. And so that's what they've been doing. But I think actually stopping it is going to be very, very difficult.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Now, our next question is from Barry in Brundle, who says recently he had a swelling on his face and the doctor reckoned it was to do with biological washing powder. So he changed to non-biological and it seems to have cleared up. He was wondering whether that's a common thing.
If something just clears up, it isn't necessarily because of you stop using something. Lots of things just clear up of their own accord. So, but there is a difference between biological washing powder and normal washing powder, and that's that they put a load of enzymes into biological washing powder which break down things like food which you've got stuck on your clothes. So there's various things like proteases, and some of these enzymes people can be allergic to and can cause issues.
Yeah.
So it could quite possibly be the biological washing powder, but it's always hard to tell with one person, because lots of problems, medical problems, just sort of seem to get better of their own accord.
Let's get to our email now over here. We have Marcus, who sent an email in. Why is it hard to perceive blue at night? See, my little shaky torch is blue. It's a kind of bluey light. So why is it hard to perceive blue at night?
I think it's definitely harder to focus blue light at night time. Because at night time, what happens is your pupils open right up, and you've got really big pupils, and so you're using the whole of your lens. When you're using the whole of your lens, then any errors are much exaggerated. It's the reason why people who are short-sighted and they haven't got their glasses on, they tend to squint. That basically makes their pupils, effectively makes their pupils much smaller. And therefore, any errors in the shape of their lens, which there is one because which is the reason why they're short-sighted, are much less an effect. So they can see things better, even though there's less light getting through. And also your lens is only optimised for one colour of light, and that colour of light is some sort of greeny, yellowy colour. And the further in the rainbow you get away from that, either towards the red or towards the blue, the less well optimised your lens is for it. So the more out of focus things are. And so if you're, and so basically if you're looking at a blue light and your pupil's right open, so all the errors are maximised, anything you look at in the blue is going to be more out of focus than a green or yellow.
Now, Tony in Chelmsford has said, if he leaves a dusty bin lid on his garden for 4 days, the grass dies as it gets no sun. However, when the grass is covered with snow, the grass is still fine when it clears, yet it's still not getting any light. Why is this?
I think the big effect is essentially if grass goes below a certain temperature, it's somewhere, my dad knows this off the top of his head because he used to be a farmer, it's somewhere between sort of 4 and 8 degrees C. It basically stops growing and it sort of goes into hibernation mode. And the chemical reactions which cause grass to grow and all slow right down, and it essentially just hibernates. And in that state, it doesn't need any light because it's not doing anything. It's just sort of sitting there and waiting for the weather to warm up. Whereas in the summer, when it could be growing, then all the chemical reactions which get rid of the green pigment are going faster, it's losing water faster, all the reactions which use up energy are going quickly, and so it puts all its energy into trying to escape from this dark area and getting somewhere it can get some light, and therefore it will die off much quicker.
All right. One on the email hill from Emilio. What a lovely. Emilio Romero. He says he enjoys the show and he wonders, could we develop an underwater GPS?
I mean, the big problem with the reason why GPS doesn't work underwater is that GPS is working in the microwave region of the spectrum, and microwaves don't go through water very far. So as soon as they hit the water, they get absorbed, and you can't hear them, you can't pick them up. The only things which really go through water very well are either very, very long wavelength, things like radio waves at extremely long low frequencies, and sonar. The ELF radio, the wavelengths are thousands of kilometres long, and it would be almost impossible to work out where you are, because you know where you are to within maybe a tenth of a wavelength or something, but that's still 100 kilometres and not a lot of use to you. So you'd have to do it with sound, with sonar. It does get a lot more complicated because radio waves through the atmosphere go approximately in a straight line. They'll get slightly bent by clouds and things in the air, but near enough, within sort of 10 or 20 metres, they're going in a straight line. And so you can work out pretty much where you are. Whereas sound waves underwater, they can go all over the place. They can even get reflected, they can get bent, all sorts of strange things would have to happen. So it would be possible to do some kind of positioning system with sound waves underwater. They do it. They haven't built a kind of global system because intrinsically it's a lot smaller scale, because you need a transmitter. The oceans aren't very deep, so you'd need transmitters sort of regularly over sort of the size of depth of the ocean, so you need one every sort of 5 or 10 kilometres. And so they have built sort of small positioning systems, sort of if you're under a drilling ship or when you're using these remotely operated vehicles, these underwater robots. And they do build some kind of positioning system, and they work out where they are by sending sound pulses backwards and forwards. But yes, globally it would be a lot more difficult because of all these kind of distortions and things.
All right, well, let's go to this one here. I'm talking about radio and that kind of thing. Richard in Hertford says, why is it I cannot get digital radio on my narrowboat? Dave?
Yeah, I have a similar problem. The only way we can get DAB radio in our bedroom is to put the radio right next to the window.
I've stopped using mine.
Various reasons. One of them is it's a slightly higher frequency, and the higher the frequency, the less well radio waves sort of go around corners and go through walls and things. So it's slightly less good at going through walls and going around corners. So if you're on the edge of reception with FM radio, if you go on to DAB radio, then it's probably the reception's a bit worse and you won't pick it up. And of course the other thing, which I don't really know about, we'd have to go and talk to the engineers here, is whether they're transmitting quite as powerfully or from the same place with DAB radio as the FM radio. So you might not be able to pick it up because there isn't the same transmitter near you.
Well, let's hope that it gets sorted out. It's not long, is it? Now, some more here coming up. Billy says, when you drink a hot drink, your mouth withstands heat. If you spill it on your legs, it's painful. So does your mouth just adapt to hot drinks as you grow? If you're 40 and never drank hot liquid, would it scald your mouth? That's an interesting question.
It's an interesting question. I'm not an expert on this. I don't really know a lot about it. All I can say is that I don't like tea or coffee, and I find it quite hard to drink hot drinks. So I think quite a lot of it is learning how to drink hot drinks. Because some of it is if the drink's very, very hot, you tend to slurp it.
Yeah.
So as it comes out of the cup into your mouth, lots of air is going past it, which cools it down. And I think possibly the top of your tongue might get thicker as well. Things which might help is if the skin on your tongue gets thicker, then it would be better at absorbing the heat, and probably you get more tolerant to the pain as well.
Yeah, because it doesn't matter how hot things are, sometimes you still have to drink them. Where have we got now? Oh, there's one here that's coming from Nigel, which is quite interesting. Nigel says, I've got a question for Dr. Dave. I heard on the QI programme last night that bacteria are possibly being used to harvest the platinum from our roads when it's ejected from the catalytic converters. Have any other uses for this principle been experimented on? There must be tons of lead in the environment. That's from Nigel.
Yes, there's certainly been using bacteria and things in swamps to get metals out of, to kind of catch metals from sort of the sewage outfalls. So you treat the sewage and then you put the output of that through some kind of sort of marshy swamp things, and there's lots of bacteria and plants that have evolved. They've grown bred plants which are good at catching certain kinds of metals. They think that actually quite a lot of the gold fields in South Africa and that sort of area are ancient bacteria which for some reason collected gold for reasons we're not quite sure evolutionarily, and they collected lots of gold and then they died, and so they concentrated gold in one place, and that's actually what you're digging out of the ground. There's actually an example, I think it's in Niger, where sort of several billion years ago there was a kind of bacteria which for some reason started concentrating uranium from the environment. And in those days, actually, there was a lot more uranium-235, which is the stuff which will fission. And these bacteria collected lots and lots of uranium until they collected so much of it that it turned into a nuclear reactor, and it went critical. And it actually started really heating up, and there's all sorts of evidence of this from the products from this. And so the first nuclear reactor on Earth was billions of years ago, created by bacteria, not built by us 50 years ago. Wow,
how about that then? Interesting stuff. Let's have another question on the email here. This one comes from... Oh, they haven't put the name. Why do colliding steel balls burn the material between them?
Yeah, that's an interesting one. If you get two very large ball bearings and crash them together with a piece of paper, the piece of paper actually burns. It's basically because the steel ball bearings are very heavy. They've got lots of energy when they crash together. And also the steel is quite elastic, so when they bash into each other, that doesn't absorb very much energy. So all the energy from that collision must be absorbed by whatever's between them. And if what's between them is paper, then it's going to absorb it, and it's going to get very, very hot as it crushes and gets smaller. It heats up, and in fact it can heat up so much that it will char and burn and go black.
There's another one here that's come from Aliu, actually, on the email. Thank you for that one. It says here, how does wire pass through ice without cutting it? Oh, good question.
There's various things. One of the major ones is that under high pressure, because water is larger, when it freezes it expands. Yeah. Therefore, if water is about 0 degrees C and you squash it, it can actually gain some energy by shrinking a bit and by turning it back to a liquid. So if you apply high enough pressure to water, it will melt. And so if you've got this wire across this block of ice, if you apply very high pressure to it, the ice will melt a little bit, and the water molecules can then move around the bit of wire. And then as soon as they've got around the wire, then the pressure drops, and then they can refreeze. So very slowly the water molecules can move from the bottom of the wire to the top of the wire, and the wire can move down slowly through the block of ice, and it's solid all the time.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.